Okay, good evening. All right, so first off, just to wrap up the midterm. So I graded your midterms. You should be able to see your grades on Blackboard. Somebody write that here. Okay, so you should be able to see your grade for the midterm one right next to the homework grades. And I also posted my solutions that you probably saw for the midterm. Okay, those are right there. So if you missed any points, you can see what my solutions were for the midterm, and so also the midterm one solutions are posted. Okay, so the class did pretty well on the midterm, and so the grades were pretty high, and it seemed like you guys understood the material pretty well, and so I was happy with the results there. Any questions on the midterm? It seemed like you all did pretty well, but any questions on midterm grades, anything like that? Okay, well, if you look over the solutions or if you have any questions on the midterm, please let me know. And again, it seemed like you did pretty well. So I'd expect the same on the next couple of games, but nice. Okay, so post midterm, we're on the kind of the second third of the class. Last week we did chapter 6. Okay, and today we have 2 chapters. So it should be a full day tonight. These chapters aren't too long, but I do want to cover 2 chapters that kind of go together, which are chapter 7 and chapter 8. Alright, so we'll try to get through these today, and then you'll have a couple homework assignments for these. So let's go ahead and start on today's material. We'll start with chapter 7. Okay, so you can open up the chapter 7 study guide and the chapter 7 examples if you want to do that. Okay. And you can open up the PowerPoint for chapter 7 as well. Okay, so let's go ahead and get started. So chapter 7 begins we're going to look at, in the next few chapters, some different types of market structures. And those 4 types of market structures we're going to look at in chapters 7, 8, and 9 are listed here on slide 2. So let's look at those to see kind of what we're doing today and what's coming next week. Okay, so these are the 4 market models that we're going to look at and talk about and study for the next couple weeks in the next 3 chapters. So this chapter is pure competition, which is chapter 7. Chapter 8 is monopoly, pure monopoly. And then chapter 9 are these other 2 types, which are monopolistic competition and oligopoly. So we'll go from varying degrees of market power and different types of market structure. And so these are the 4 types we're going to learn about in the coming weeks. And so we're going to start with kind of the most basic, which is called pure competition. Then we'll look at monopoly later today in chapter 8. And we'll cover these last 2 types, monopolistic competition and oligopoly. And those will be covered in chapter 9. Okay, so as we go along, make sure you kind of understand the distinct features and what kind of makes and defines each type of market structure. So the first type of market structure we're going to talk about is pure competition. Okay, so let's look at the characteristics on slide 3 and also the type of market structure that this is going to result in a perfectly elastic demand curve. Okay, so let's talk about that. Let's get this market introduced on slide 3. Okay, so these are like the bullet points of pure competition. So you can think of this as a market where there's a very large number of sellers, so there's no limit on the number of sellers in this market. Hold on one second. Okay, so this type of market is a standardized product or a homogeneous product. And so another way to think of this type of market is that these goods in this market are perfect substitutes. Alright, so that means in this basic type of model that all the firms in each industry sell the same exact or identical or homogeneous product. Which also means that these firms are going to be price takers and basically long run supply and demand determine the price. But in the short run, the firms have no influence over price. They can either choose to sell a certain amount of quantity at the market price or not. So there's no market power by the firms, and they have no influence and no control over price in the short run. So therefore, we call them price-taking firms in this type of market. There's easy entry and exit, which means that if firms are able to operate, given the cost structure and sell in this type of market, there's no barriers. They can do that. So anybody that's able to operate a firm in this type of market can come in or exit or enter. Okay, so that means that this market is going to result in a perfectly elastic demand curve in the short run. And firms have one decision, basically, is should they produce, and if so, how much. And they don't get to choose the price, but they do get to choose how much they produce. Okay, so with a perfectly elastic demand curve, we can see that the price is set, at least in the short run, and the demand curve is just a horizontal line because that represents, remember we talked about elasticity. We talked about the perfectly elastic demand curve, and that's going to be the type of market here, where you have that horizontal demand curve that looks like this on the next slide. Okay, so if we go to slide 4, we can see what the demand curve looks like. And we're also going to introduce average total and marginal revenue. And those are going to go along with the demand curve, which again is going to be perfectly elastic. So let's look at slide 4 for a minute. Okay, so see, before we talk about these other types of revenue metrics, let's focus here on the demand curve. So see, the demand curve on this slide is just a green horizontal line. Right, so at a price here is 131. That's the demand curve in the short run. So you can see there the demand is that horizontal line, and in this type of market in the short run, we always have a perfectly elastic demand curve. Okay, so the firm states a perfectly elastic demand curve in the short run. So you see that horizontal line there. So let's think now if we can think of some examples of a market that operates under pure competition. So can we think of some examples of a market that might qualify for pure competition? So what are some examples of goods and services that might be sold in a pure competition market in which we have this perfectly elastic demand curve and firms are price takers? So can we think of any examples here of this type of market? Okay, so we have to have a market in which we define the goods and services as perfect substitutes. So that means that in the industry that, again, all the firms in that industry that operate are selling the same exact identical product, right? So they're homogeneous products. So this type of firm or this type of market usually depicts something like agricultural or like a farmer's market type of situation. So let me see if I can present some examples so this type of market makes sense before we talk about it more. Okay, so the best way to think of it, how this type of market is defined, is that if you think of a simple example like a farmer's market, so you have like a couple sellers of the same exact good. So let's say we have an example of a farmer's market where there's two firms or two vendors selling the same exact apples or something like that. Okay, so if you think of a farmer's market where you have a vendor one is selling apples, vendor two is selling apples, and the apples are identical, so that means they're the same exact apple, same quality, there's no brand names, right? It's the same exact thing. So the only difference is you can buy from vendor one or vendor two. And the way you can see how kind of price is set for the market is that if you went to the farmer's market and you saw these two vendors selling apples, and let's say they're the same apples. Let's say one vendor sells them at, I don't know, 50 cents an apple. Okay, and vendor two sells apples at $1. So again, the way we set this model is you're at the farmer's market. There's the same, they're both selling the same apple. And so therefore you can see that your decision is pretty easy. So if this is the situation, who are you going to buy the apples from if you're the consumer? Right? Apples from vendor one or vendor two? Okay, so just so we're clear what's happening, so who would we buy the apples from? They're the same apples. One vendor sells them for $1, one vendor sells them for 75 cents. So, yeah, exactly. Okay, that's what I'm looking for. All right, so they're the same apples, right? Why would you pay more if it's the same exact product? So in this market, the price has been set. So like this green line here would be a price of 50 cents, and that's what the long-run demand has determined they'll pay for apples. And if somebody in this market tries to sell apples at above that market price, why would any consumer pay it? Because they can just buy the cheaper one, right? So take away all like branding, take away all like production constraints. Just assume this type of market is firms in the industry, in this case the apple industry, selling the same homogeneous apple, and the only difference the consumer cares about is the price. Now, that doesn't mean that the price can't change, because if consumers decide they like apples more and start bidding up the price in the long run, then the price can increase or decrease in the long run. So that's kind of the key here. So yes. Okay, so this is what we've learned so far that helps us understand this type of market of pure competition. So in the short run, this example shows that in the short run, all consumers would buy from vendor one at 50 cents per apple. That's the market price. Now, also in the short run, all sellers of apples, including vendor two, that try to sell apples above the market price wouldn't get any customers because why would they if it's the same exact product? We would buy from them. However, consumers could bid up the price of apples in the long run if they decide that, apples are more, for some reason, demand increases, and the market says we'll pay more for apples. That can change the price in the long run. And the opposite is true, where consumers could bid down the price, where long run demand declines. So the thing that determines demand or price here is long run demand. Okay, so the only determinant of the market price is long run demand. All right, and sellers have no control over price. They just respond and produce at the market price. Okay, so that's the type of market we're dealing with, where they're perfect substitutes. Now, there's most goods. You can make a case are different than this. Like if you start talking about different brands of apples or different types of goods that have different features, organic, good, Fuji apple, stuff like that. So if we start breaking them down into categories, then it's a different market. But in this market, the assumption is that all the goods are homogeneous. Okay, so that brings us back to this slide. Okay, so we learned about all the cost structures last time, and so here we're just introducing the different types of revenue the firm gets. So we have total revenue, which we know what that is, right? So remember we learned that from question 2 on the midterm. Total revenue is just the price of the good times the quantity sold. Okay, so we know that. Let's define average revenue, which is just revenue per unit. So this is just the total revenue divided by Q. So how much revenue per unit. And then importantly, marginal revenue. This is the extra revenue for one more unit. So when you sell or produce one more unit of this good, then what's the change in revenue? So what's the change in revenue if you increase output by 1 unit? Okay, so if you look back at this graph, so the first thing to notice is we have the perfectly elastic demand curve, right? So the market price is set at 131, and that's going to be the price unless there's some long run adjustment in demand. But for now, the price is set at 131. That's what we're dealing with. So that's what the firms are dealing with. So their only choice is how much do they produce at the price of 131. Okay, so you can see that no matter what the output is, the price is always 131, and so therefore the revenue on the margin is always going to be the same. Okay, so see that if okay, let's see how we can see it. So these are the 1 unit changes. Okay, so if you produce 1 unit, you get an extra 131 in revenue. Right, if you produce 2 units, you get another 131. If you produce 3 units, you get another 131. So each time you produce one unit in this picture, you get an extra 131. Okay, so in this graph, the marginal revenue is always 131. All right, so that means that in a pure competition market, the price is the marginal revenue is equal to the price because the price has been changing. So each time you produce one more unit, you get an extra amount of that price, right? Okay, so price equals marginal revenue in pure competition always, and that's because the price is set, and each additional unit gives us the same extra increase on the margin, right? For 131, sell another unit, another 131, and so on. So your additional revenue on the margin is always equal to the price because the price is constant. Okay, and then you can see total revenue increases kind of here in a straight line because each time you sell another unit, you get another P times Q, right? And that keeps increasing. But note that the demand curve is equal to the marginal revenue curve, which is this green line here. Okay, so given the type of market we've defined, let's see if we can determine what the firm would do. Like they have a profit maximization choice given the market price. So profit maximum is short run for a peer competition firm. Let's look at those decisions on slides 6 to 13. Okay, so these are the questions the firm is asking itself in a peer competition market. Is number one, should the firm produce? Number two, if they should produce, how much should they produce? And then are they going to make a profit or are they going to make a loss given their decision? So produce, yes or no? If they produce, how much? And then do they take a profit or do they take a loss? Okay, so we'll look through these slides in a minute, but this is the optimal profit maximizing rule is this here, where MR equals MC. Okay, so that's what the firm is going to look for, and then at that crossing, they're going to choose their quantity at that case. So when what's the quantity they could choose when MR equals MC, right? And then that's going to help determine if they make a profit, if they take a loss, or if they should just shut down. So we're going to have a number of cases, but it starts with this rule. Okay, so a firm should always produce the Q star, the output, that results when MR equals MC. Alright, so if we look at the graph and the chart, this will make more sense. So we're trying to answer the first question here, should the firm produce? And if they should produce, how much? Okay, so we're gonna have, I guess, three cases. One where the firm produces and makes a profit. A second where the firm produces and minimizes losses. And a third case where it's too costly to produce at all, and the firm just shuts down. So there's three distinct cases that we're gonna analyze here. Okay, number one, produce and make a profit. So that's the best case, obviously, for the firm, because they're producing and they're making a profit, just like we saw in the examples we did in chapter 2, where like the banana bread or the Girl Scout cookies, who they determined they were making short run profits, so they keep producing because they're making a profit. Yeah, the second case is where the firm produces and minimizes losses. So this is where it's not profitable, but it's better to keep producing because at least they're covering the fixed costs that they've already spent on the business operation. So then the third case is just shut down and stop producing. Okay, so let's look at these three cases graphically and kind of how that represents the firm's decision. So if we look at the next slide, we're first going to look at the firm produces and makes a profit. Okay, so if you look at this, I have a lot of columns here, but if you look at the chart, you can see that we got column 1, which is the total product, this number of units produced. Column 2, which is the average fixed cost. Column 3, which is average variable cost, right? We learned these in chapter 6. Average cost is just that cost divided by Q. Column 4 is average total cost. Column 5 is marginal cost, the change in the margin. The other column 5 is the same because price equals MR. So it looks like there's two column 5s, but and then column 6 is the profit or loss. So look at this term, its decision to make is the first find when MR equals MC. Okay, so that's the case when MR equals MC, right? This is MC is 130 and MR is 131. It's pretty much the same. And you can see why that's the case, because if any production decisions below that, look at the profit, it's less than this case. Okay, and look at the profit above an output of 9. So 9 would be the optimal quantity, and they're making less. So the only situation in which they're getting their best profit is the case where MR equals MC, which is the Q star equals 9. Okay, so if you look at the chart, you can see where I wrote in the chat that the firm chooses Q star equals 9 because that's where MR equals MC. And you can confirm that's the right decision because any Q star below 9, the firm can produce more and make more profit. So look at the profit, and it's lower, except in the case, and then if it produces too much, any Q star above 9, it becomes more and more costly and the firm's losing profit with each unit produced. So kind of the sweet spot here is the Q that coincides with MR equals MC, and that's always the case for the firm decisions. Okay, so the questions for this firm are, yes, it should produce. It should produce at Q star equals 9, and it's going to make a profit of $2.99, right? So this is the best case scenario. This is the profit maximizing case, case 1. Okay, so if you look at this graphically, so we learned about all the cost curves in chapter 6. Okay, so we got marginal costs, average total costs, and average variable costs shown here for this firm. And so we're plotting the data from the chart. On the graph. So this is the same thing, it's just graphically. So here is where MR equals MC. So right here's the MC curve, the blue curve. And here's the MR curve, which is the black horizontal curve, which is also demand. And the output, where MR equals MC, is 9, see? So that's what the firm is doing. And you can see that this profit is just calculated like geometrically. So the profit, or the revenue, let me write this here. Okay, so we know that the revenue of the firm is just price times quantity. So the price is 131, that's set. If it produces 9 units, then obviously 131 times 9 is the geometric profit. The cost is the average cost, right? So this is the cost on the red line at 9. So the cost at producing 9 units is 100. So if you just subtract the cost from the revenue, you get the remainder, which is the green part, and that's the revenue, right? That's the profit, right? So the big revenue box minus the cost box gives us the remainder, which is the green area, which is the profit. Okay, so do we see that kind of how we're getting that from the graph here? Okay, so this is the first case where the firm produces at MR equals MC and makes a profit. So this was the case. This was the profit maximizing case. Okay, so that was the problem max case. The next case is the same process, but this firm, given its cost structure, is going to keep producing, but instead minimize losses. So they're going to take a loss, but it's still better than shutting down. All right, so here we go. This is the loss minimization case, case 2. So we're still gonna produce because the price is high enough for us to make a loss minimization case. So the same profit maximizing rule where MR equals MC, but it just turns out that the firm doesn't make a profit in the short run. So look at the next chart. Okay, this firm still produces Q star where MR equals MC, so it's still the rule they want to follow. All right, so look at the chart and you can see what MR equals MC. That's also at a Q star of 9. Sorry, that's not. I don't know why that's. This is the Q star equals 6 should be the right, the bold part. Yeah, so Q star equals 6 is the best Q for this firm. So see on the chart where MR equals MC. All right, so here's MR at a Q star of 6. MR is 80, and or MC is 80 and MR is 81, so they're pretty much the same. And if you look at the resulting profit or loss, anything above it, or any quantity below Q star equals 6, they're going to take more of a loss. And if they produce more than that, they're going to take more of a loss. So they're always taking a loss, but this is the best case they can do given their cost structure. Okay, so the best case is to minimize loss at $64 for this firm. And the reason why they wouldn't just shut down is because shutting down, they still have to fork up the fixed cost, and the fixed cost is 100. So see what that means without producing any output, they've already lost $100. So producing not at all is definitely worse than losing 64, whatever this is. So basically, losing 64 is better than losing 100. Okay, so hopefully we see that producing and losing 64 is better than shutting down and losing the fixed cost. You've already paid that, or the firm has. So its best case is to keep producing and minimize losses at where MR equals MC, and at least cover the fixed costs by producing and minimizing losses. Okay? So that's case 2. We can see that graph on the next slide. Okay, so this is the same analysis we did before. The only difference is the firm's cost structure is higher. Right? So you see how the price is lower than the average total cost or the average variable cost. So here you calculate profit or loss in the same way. So revenue is 181 or 81 times 6. Then cost is what's the average total cost at 6. That's the red line there at 100. So cost is 100 times 6, which is 600. So profit is still the same calculation where it's revenue minus cost. This turns out in this case, cost is higher than revenue, so it's a negative or a loss. So same, way we did it on the graph, but the best case this firm could do is produce 6 units, minimize loss, where cost is a little bit higher than the revenue it makes. Right? So you can see that there. Okay, so that was the loss minimization case. The third and final case is when the firm just shuts down completely and doesn't produce at all. Okay, so the profit maximizing rule of MR equals MC, the firm can apply it here, but you can see that if you look at any of these situations, 1 through 10 or higher, the firm's going to lose much more than the fixed cost. So there's no case, given their cost structure, which they can produce and be better off than just shutting down. So if they see this opportunity and they see what's going to happen, the firm's going to see that, all right, they've already lost $100. Okay, that's the fixed cost of this operation. But producing 1, 2, 3, any number of units up to 10 or beyond, the resulting loss is higher than the fixed cost. So this firm's just going to shut down because it's too costly. Okay, so you can double check where MR equals MC, which is right there. MR equals MC is when Q star is 5. Okay, so M arc of MC is what we normally do, but you can see at that result, the best output they can produce, if they want to produce, is 5, and that's going to give them a loss of 115. But clearly it's better off for the firm just to shut down, because losing 100 is better than losing 115 or more, right? Okay, and you can see that one graphically here. Well, we're not even going to calculate the profit because the firm's just going to produce 0. So you can see that any number of options that the firm produces, you can do the profit loss calculation. You're going to get a higher loss than just shutting down and losing 100. So the market price is too low for this firm to make any kind of profit, and they're just going to shut down and not produce at all. So the best case would have been C star equals 5, but that's still going to give them a loss of 115. Okay, so those are the 3 cases that we discussed so far. And so it kind of brings us to this rule. If you go back to the Word document. Okay, so this is the cutoff for making or for producing and not producing. So the firm's going to produce if price is bigger than the minimum average variable cost, because that's the turning point at which they can cover the fixed costs. Okay, and if they can't cover if they can't even cover the fixed cost, then they're just going to shut down because it's more loss minimum. It's better just to shut down and take the full loss than produce it all. So the price has to be at least equal to the minimum point of the average variable cost for the firm to keep producing. Otherwise, it's just going to shut down. Okay, so that kind of summarizes the main points for this profit maximizing cases in the peer competition market. So we have back to the original question. All right, so the first question was, should the firm produce? And the answer is yes, if the market price is set equal to or greater than the minimum point on the average variable cost. Okay, so this means that the firm is at least going to be profitable enough to offset losses. And the second question, okay, so that's the first thing. If the market price for this good or service is at least higher than this point here, right? So if it's at least higher than the minimum point, or not that point, but yeah, that's the point. Yeah, that point. So this point. So if the market price is at least higher than this point, in this case it's not, it's going to produce. Okay, if it's not, like this case, they're going to shut down. And then do they make or how much do they produce? Okay, so they're always going to, if they produce, they're always going to produce at the Q star where MR equals MC. That's the best case scenario for the firm to choose its output, given the price. Okay, so and then if it produces, we'll make a profit, and so that's going to be yes if price exceeds average total cost, and no if it doesn't. So this kind of covers the three cases where should the firm produce, how much should it produce, and then is it going to make a profit? So the recipe is the same. It just depends on the cost structure of the firm and the market price. Okay, so we just covered a lot there in that little section, but that was kind of the bulk of the chapter, was trying to understand the different types of firms should they produce, how much should they produce, and will they make a profit. So everybody doing okay with what we've covered so far? Any questions on the firm decisions and the graph so far? Okay, so if questions come up, let me know. This is a little difficult to comprehend if you've never seen it before, but we'll do some examples if the exercise is point. So let's look at, given what we've learned so far, how we would define the short run supply curve. On slide 15. Okay, so this looks like there's a lot going on here, but it makes a lot of sense if you comprehend what we just learned. So we learned that the firm is going to produce if the price is at least equal to the minimum point on the average variable cost, which here would be point B. Okay, so that means they're going to start supplying at that point, right? So any price above point B, the minimum point of the average variable cost, the firm is going to produce. Okay, so that means that the marginal cost curve is exactly the supply curve above that point. And at any point below point B, they're not going to produce, so that's not part of the supply curve. Okay, so the firm would start supplying at price equal to point B, and any price above that, and they would not supply at any price below that. So therefore, the portion of the marginal cost curve above the minimum produced point is exactly the supply curve. So you see that here, the blue part of the supply curve that's not dotted. Alright, so that means that like at a price of P1, they're not supplying at a price of P2. That's when they start supplying. At any price above P2, they will supply. And so the marginal cost curve is going to represent the supply curve as long as they're going to start supplying at any point above point B. Okay, so again, let me write what I said here. Okay, so a firm's short-run supply curve is a portion of the marginal cost curve above the point where price equals the minimum of the average variable cost. So it's either any point above that point B, on the lowest point on the average variable cost, they're going to supply, and that represents the supply curve, and then any point on the marginal cost curve below that, they're going to shut down, so they're not going to supply. All right, so you can see how that translates into the supply curve for the short-run firm. Okay, then what about, so all these cases have been short-run scenarios. So what about the long run? So what does profit max and the graphs look like in the long run? So let's look at slides 18 to 22. And so we've looked at the decisions for an individual firm in this market. But in the long run, you can have adjustments to the market price. So in the long run, you can have potential profits in the short run for the firm. But firms that enter the market are going to eliminate the profits in the short run. And the firms that are making a loss in the short run, some of the firms are going to exit the market. And so loss, or firms that exit, are going to eliminate losses in the short run. And let's look at what the long run case look like. Okay, so again, this is panel A is a single firm, which we've been talking about. So they have the perfectly elastic demand curve, but the supply of the industry is a normal upward sloping supply curve. So see the industry, which is all the firms. So in the long run, the demand can adjust to push the price up or down. So see how the intersection of the industry supply and the industry demand determine the price. So like the Apple thing, if demand determined they'd pay 75 cents for an apple, that would be the market price for Apple. Okay, and here the consumers have determined they would pay $111 for this good or service. Okay, so that's kind of the intersection of supply and demand in the industry determines the short run price for the individual firm. Okay, but things can change, like the next slide. Okay, so entry and exit is the only kind of long run adjustment we consider. So let's look at what happens if the demand for a good or service changes. So if you look at this next one, we're going to look at two graphs. The first being where entry eliminates profits. So demand increases, and therefore there's profit opportunities for the firm in the short run, and that induces more firms to enter, which means supply increases, and prices fall in the long run. Now the other case will be where demand falls, and because of that, firms start to exit because they're making less revenue. And that by definition means that supply decreases and that prices rise in the long run. So let's look at the first case where there's short-term profit opportunities for firms. Okay, so you see this. So start with the minimum. So the long-run equilibrium is the situation in which price equals the minimum point of the average total cost. So that's exactly the shutdown point, and where the marginal cost crosses the price. If you see that there, that's the minimum. That's the minimum case. So this is the indifference point between shutting down and not shutting down, and also where MR equals MC. So if something changes in the short run, for example, demand increases from D1 to D2. All right, so they're bidding at the price, and that means that firms see this short run profit opportunity. They make profits in the short run, but in the long run, supply increases and the price is pushed back down to 50, and there's no more economic profits in the long run. So let me summarize kind of what this shows. All right, so this is a case, this graph shows where we started the price is 50, where we're at the equilibrium point, but then in the short run there's an increase in demand, which means there's profit opportunities for the firms in the short run, so they take it. So here the firms bid up, not the firms, the demand, consumers bid up the prices, not the firms. All right, so consumers, not the firms, sorry, they bid up the prices in the short run, which is another way of saying demand increases. So you see you go from the green D1 to D, so demand shifts out, right? And then firms see that if the price goes up, there's profit opportunity to be made because each unit sold at that higher price is more profit. So firms see this profit opportunity and enter the market, or the current firms increase supply. So the firms make a short run profit here, right? But in the long run, see the increase in supply pushes the price back down to 50, and what this market tells you is in the long run there's no economic profit. Okay, so that's the case of short run profits, but again in the long run there's profits or economic profits are exactly zero. So the next one is when there's losses in the short run. All right, so see here where we started 50, and this is a market where demand falls. Okay, so demand falls from D1 to D3. Okay, and that means that they're bidding down the price, and so firms are going to take short run losses, right? So firms are going to it's the loss minimization cases we talked about in the short run. But in the long run, firms exit or decrease supply, and the long run adjustment goes back to a price of 50. And so here we have short run losses, but economic profit in the long run is exactly zero. Okay, so here we have short run losses for firms because demand decreases in the short run. But in the long run, there's adjustments. Firms leave the market, and economic profit goes back to zero. And so in both cases, there's opportunities for economic profits in the short run. And there's also cases where the firms take a loss in the short run. But in the long run, what this model says is that firms make zero economic profit. All right, so last thing here is the long run equilibrium of a competitive firm on slide 26. Okay, so in the long run, both these things are got to be true. Price is equal to the minimum point on the average total cost curve, and this is also where price equals MC. So if you look at the long run graph, okay, the long run equilibrium is here, where the price is just equal to the shutdown point, the minimum point on the average total cost, and this is also where the price equals marginal cost. Alright, so this is always the long run condition. Both those things have to hold. Price equals minimum of average total cost, and price equals marginal cost. Okay, so those are the conditions for the long run equilibrium to hold. And you can see the kind of the relation to the short run decision, where in the long run we're saying that the price is exactly equal to the shutdown point, and this is also the case where the firms are operating at their MR equals MC profit maximizing rule, but making zero profit. Okay, so that's kind of what we showed in this type of market. Alright, so here we go. This type of market represents perfect substitutes, right? And we can see that given demand, if that changes, firms can make short-run economic profits. But if demand falls, they can also result in taking losses in the short run. But in the long run, all the, supply and demand adjust. If they do, then the firms that are left in the industry make exactly zero profit, and that's the case where price is the minimum point of the average total cost curve. Okay, so those are the key points and the key summaries from this chapter. There's some optional videos on curve of competition and the supply curve. You can look at those. All right, let's look at some examples. So number one, let's use the demand schedule below to determine total revenue and marginal revenue for each of the possible levels of sales. So here we got different prices and different quantities, and we have to calculate total revenue and marginal revenue. All right, so you can see that the price is set at $2, and there's different quantities the firm can sell at. All right, so total revenue is just price times quantity. So the total revenue here is just 2 times 0, 1 times 2, 2 times 4, or 2 times 2. All right, so total revenue is price times quantity, and then marginal revenue is the change on the margin when you go from different quantities. So the change is always 2 because the additional revenue is always 2. Then part A, or the next part is what can you conclude about the structure of the industry in which this firm is operating and why? So the structure of this industry is pure competition. We know this because the price equals demand, which always also equals marginal revenue. So because the price is fixed at demand, that indicates a pure competition industry. Okay, and you can graph the MR curve and the total revenue curve to confirm it. So if you wanted to graph the demand, total revenue curve, and marginal revenue curve, you would see you get a perfectly horizontal demand and MR curve. So you don't have to do this, but you can see I did this in Excel where I put the table here. I calculated revenue based on just price times quantity. And the change in revenue from each additional unit sold, which is always 2. And then if you graph that, you'll see that you get the perfectly horizontal demand curve at 2. And the total revenue curve increases because each time you get 2 more P times Q's. All right, number 2. Okay, so let's do this one. I think there's a homework question similar to this one. So let's go through the profit maximizing choice for a hypothetical firm. All right, number two, the cost function for a firm is total cost equals 25 plus 5q squared. All right, so basically the 25 is the fixed cost, and the 5q squared is the variable cost. Okay, with a marginal cost function of MC equals 10q. So part A, if the firm sells output in a perfectly competitive market, and other firms in the industry sell output at a price of 100, what price should the manager of this firm put on the product? Okay, so this is pure competition, which means the firm's a price taker, and if the market price is set at 100, then to operate in this firm, they have to charge $100, at least in the short run. So if price is set at 100, these firms are price takers, the price is going to be 100. Okay, part B, what level of output should be produced to maximize profits? And that's the point, remember when MR equals MC, that's the profit maximizing rule. So we also know that in pure competition, MR equals P. Okay, so MR equals MC is the profit maximizing rule, but in a pure competition firm, we know that price equals MR, so therefore you can set price equal to marginal cost because price is the same thing as MR. Alright, so here's the general condition. Here's the specific case for pure competition because we know that price equals MR, so we substituted pricing for MR. So now it's P equals MC. Alright, price is 100, and we were given the marginal cost of 10Q. Alright, so all we did here is set the two equal and then solve for Q. So 100 equals 10Q, just divide by 10, and we get an optimal Q star of 10. Alright, so you look at the point where MR equals MC, and then find the Q star at that condition. Alright, then how much profit will be earned at that price and quantity? So you know that profit is total revenue minus total cost. Total revenue, is price times quantity, right? And total cost is given this total cost function. Okay, so just plug in the numbers now. Price is 100, Q is 10, and then subtract your cost. So it's minus 25 the fixed cost, and then minus 5 times Q squared, and Q is 10, so plug in 10 there. And if you solve for this, you get 1,000 minus 25 minus 500. So that gives us a corresponding profit of 475. Okay, so for this type of problem, the price is given, and you want to choose output where MR equals MC, which in pure competition is price equals MC. Okay, and then find the Q star that goes with that. And then once you have P star and Q star, just solve for profit, which is revenue minus cost. Revenue is the price of the good times the output, and then subtract the total cost with the output at whatever the Q star is. Okay, questions on this problem? There's one of these in the homework, so if you have questions, let me know, because I can go over it again. Okay, so that's chapter 7. We'll come back to. Okay, great. All right, so that's chapter 7. I'll pull up the homework in a little bit, but let's. We have one more chapter to cover. The next chapter won't take too long, but I want to cover the key points. No, there's no homework due today, so there's no homework from. I had no homework last week. Okay, so today's the first time I'm finding homework since the midterm, so there's no homework that gave. I gave you guys a week off for homework because I knew we had 2 chapters today. All right, so let's do the monopoly stuff for chapter 8, and then I'll bring up the homework assignments. Okay, so we have another chapter to do, but it shouldn't take too long. It's just I want to cover the key points of monopoly. Okay, so I'm going to pull up the chapter 8 study guides and the chapter 8 PowerPoint. Alright, so chapter 8 is just to cover the main features of monopoly. So this is kind of the opposite of pure competition. Alright, so chapter 8 is pure monopoly, and let's define a pure monopoly with some of the characteristics and examples starting on slides 2 to 4. Okay, so a monopoly by definition is if there's only one seller of a good or service in this market. So there's a single seller. It's the complete opposite of pure competition. There are no close substitutes. Okay, so if it's the only seller, there can't be any substitutes, or else there'd be more than one seller. And therefore, the monopoly is considered a price maker because they have absolute control over their price. Okay, and therefore, for whatever reason, in this type of market, there's blocked entry. And so some barriers exist in which other firms cannot come into this industry to leave it with the only one firm selling this good or service. Okay, and because there's no other firm selling this good or service in the industry, the monopoly doesn't have to worry about price competition because it's the only firm selling this good. And so competition from other firms isn't a factor here because they get to set their own price. So monopoly, single seller, and they're a price maker of this good or service. All right, so the best examples of a monopoly that exist, that you're probably well familiar with, are most of the public utilities. So the gas company, the electric company, the water company, the trash company, the trash service. Those are all the only provider of that good or service in the area. All right, so depending on where you live, most likely your electricity provider is Southern California Edison, and you have no other options. You have to buy electricity from that company. Unless I know that in the city of Los Angeles there's a separate seller, like the LA Department of Electricity. Okay, so depending on where you live, you only have one choice to buy your electricity from, and the same goes for the gas bill. All right, so you probably get a bill depending where you live from SoCal Gas, and that's your gas provider. There's no other providers you can choose from, and most likely the city serves your water and trash service. Okay, so local water and trash service is most likely operated by a public monopoly. So I know that I pay my water and trash bill to the city of Claremont. So and again, all these are all monopolies because you have no choice but to get the service from that specific monopoly. Okay, so those are all good examples of monopolies that exist. So one of the important things here is these monopolies are established because other firms are not able to come into the market for a varying number of reasons. So any number of reasons can explain that. It can just be like the most efficient producer of it, where they have economies of scale. Most likely in terms of these public monopolies, there's legal barriers, like they're established as the only legal provider of electricity and so on. You could get a monopoly that arises because they have ownership of some resource that no one else has. But most likely you're going to get this case where, like Edison or SoCalGas, they have the monopoly right to sell electricity, and no one else has the monopoly right to sell electricity in that area. Okay, so that's the most likely case where you have a monopoly that has blocked entry. Okay, so you can see the big difference here is that monopolies and most firms, they face a downward sloping demand curve, not a perfectly elastic demand curve. Okay, so the individual monopoly faces a normal downward sloping demand curve that we're used to from supply and demand. So not a perfectly elastic demand curve. That was a special case for pure competition. All right, so there's your demand. There's a normal downward sloping demand curve, which represents the law of demand, stating that if the monopoly increases its price, demand goes down. If monopoly drops its price, demand goes up. And that's exactly what you would expect with a downward sloping demand curve. All right, so we define the features of a monopoly. There's one seller with no co-substitutes. The best examples, I think, are public utilities. And the demand curve is downward sloping, and the MR curve is also downward sloping. So there's a big distinction between the downward sloping demand curve and the perfectly elastic demand curve we had from the previous chapter. Okay, so let's look at a profit maximization choice from monopoly on slides 9 and 10. So the firm's going to follow the same rule, the profit maximizing rule where MR equals MC to choose its output. The big difference here is the monopoly gets to set its price. It's not just given by the market, right? So the monopoly is a price taker. The monopoly is a price maker, not a price taker. Alright, so that's a big difference compared to the previous chapter. Alright, so kind of the same analysis we did last time with the peer competition, but the demand curve is different. So you see how the demand curve is downward sloping here, and the MR curve is also downward sloping. Okay, so this is kind of the steps that a monopoly would do in choosing its best quantity, price, and profit. Okay, so these are the steps here. The monopoly is going to choose its follow the profit maximizing rule, where MR equals MC, and then choose the Q star. So you can see that on this graph, MR equals MC, right? Here's the MC curve is the blue one, and the MR curve is the gray one. So the point when they're equal is a Q star of 5. Alright, so that's what they do first, and choose output. And then what would the market pay at Q star equals 5? So take that 5 and go up to the demand curve and say the market price based on the demand curve at Q star equals 5 is 122. Okay, and then you calculate profit in the same way. Where revenue is 122 times 5, and then cost is 100 times 5, so it's the same thing. It's the big revenue box minus the smaller cost box, and the leftover, the green portion, is the profit. Okay, so the big difference here between the peer competition and the monopoly is step 2, in which they get to set their own price. Alright, so step 2 is the price maker step, as opposed to the peer competition firm, which was a price taker, and only gets to choose Q star. So that's the difference. Okay, so pure competition firms are price takers and choose only the optimal quantity, but you can see the difference. The monopoly is a price maker, and they get to choose both Q-star and P-star, okay, based on this analysis here. All right, then let's look at the last concept here of price discrimination on slides 14 and 16. Okay, so the concept of price discrimination that monopolies use is charging different buyers different prices. So it's not based on cost differences, it's based on the fact that different markets have different demand curves. Okay, so there's got to be some potential for market power. They have to be able to segregate the market, and they have to eliminate the resale effect. If the monopoly can do this, they can price discriminate and get a higher profit by charging two different groups different prices. So there's a bunch of examples. Okay, so let's go through a few of these. So business travel, like this has to do with, like, think of like when people used to fly. So if you want to travel last minute for business, you're willing to pay a higher price, whereas if you plan ahead and plan a trip from like a college student, you can get a much lower price if you plan your trip ahead. So there's different prices based on when you buy the ticket for the same flight. And utilities can charge different customers different prices based on like the solar discounts, or if you're under a lower income, you can get a lower rate. So they're able to charge different customers different prices. In movie theaters, when we used to have those they would charge different price. Like there's a lower student price, there's a lower senior citizen price, and then there's like a general population price, a matinee price. So if you can charge different customers different prices, then you're able to price discriminate like this. So this is kind of what it looks like on the graph. Well, let's say this is something like Microsoft Office, and so there's Microsoft knows that like businesses would pay a higher price for the Microsoft Office business product, so they get some extra features and they have more to spend. Whereas students would definitely pay a lower price for Microsoft Office Student, and they might lose some features, but because Microsoft knows that they have two different demand curves for these markets, they can charge the students a lower price and the businesses a higher price. And by combining those two strategies, they can get a higher revenue than just charging a single price to the whole group. Okay, so that's price discrimination. All right, so those are the main key concepts I wanted to cover in Monopoly. There's a couple optional videos on Monopoly you can look at when you get a chance. Let's look at some examples. So here we have the pure monopolist. So use the following demand schedule for a pure monopolist to calculate total revenue and marginal revenue at each quantity, and then plot the demand curve and MR curve. Okay, so you're given output at each price, and you have to calculate what the revenue would be, just P times Q, and what the marginal revenue would be, which is the change in revenue from each additional unit sold. Okay, if you did that, you get this table, where revenue is a function of P times Q, and marginal revenue is the change in revenue when you add one more output unit. Alright, if you were to plot those, you'd see you get the downward sloping demand curve and the downward sloping total marginal revenue curve, kind of like this. And again, you don't have to do this, but you can see what I did in Excel if you want to see how I got the calculations in the graph. Okay, so there's total revenue, which is price times quantity. And marginal revenue is the change in revenue when you go from an additional unit. So the change here is 6. The change from going from 1 to 2 is 550 and so on. So it's a change on the margin. If you plot those, you see you get your downward sloping demand curve and the MR curve, which is below the demand curve. Alright, so then number 2, this is the one that'll be on the homework assignment. So only one firm produces and sells unicorn frappuccinos in the country of Starbucks. International trade in unicorn fraps is prohibited. So the following equations describe the monopolist demand, marginal revenue curve, total cost curve, and marginal cost curve. So here's demand. P equals 20 minus 2Q. Here's MR, which is 20 minus 4Q. Total cost is 6 plus 2Q plus Q squared, and marginal cost is 2 plus 2Q. So you're going to use all the information that's given to get the profit maximizing choices for the monopolist. Okay, so here we go. Part A, what is the market quantity of unicorn frappuccinos? So what you want to do is use the profit maximizing rule, where MR equals MC, and then find Q star, right? Okay, so to find Q star for monopolist, set MR equal to MC, and find the Q star that results of that identity. Alright, so here's the rule, MR equals MC. All you have to do is plug in the equations and then solve for Q. So MR is 20 minus 4Q. And MC is given at 2 plus 2Q. So set those two equal and solve for Q. And you get, if you add 4Q to both sides, you get 6Q. And 20 minus 2 is 18, so you get 6Q equals 18. If you divide by 6, 18 divided by 6 is a Q star of 3. Okay, and then what price would the monopolist charge? So this is a different, the pure competition firm didn't have this step, right? But the monopolist has the market power to charge their own price. Okay, so to find Q star, plug Q star into the demand curve and solve for price. So that's what we're doing. Here's the demand curve given. P equals 20 minus 2Q. And all you have to do is plug in the Q star 3 into this. So just put that 3 in there, and you get P equals 20 minus 2 times 3. And that turns out to 20 minus 6, which is a market price, or a monopoly price. 20 minus 6 is 14. Okay, and then what would be the monopolist profit? All you have to do here is calculate profit, which is revenue minus cost. Total revenue minus total cost, same thing. So, total revenue is just the price of the good times how much is sold, P times Q. And the total cost is given. So subtract that and plug in Q, alright? So profit is PR minus TC. Okay, total revenue is price times quantity and minus the total cost function of 6 plus 2Q plus Q squared. And now let's just plug in the P's and Q's and solve for this. Monopoly price is 14. Monopoly output is 3. And then minus 6 minus 2 times 3 minus 3 squared. Just plug in the Q stars. That'll give you 42 minus 6 minus 6 minus 9, which gives us 42 minus 21, and it gives us the resulting monopolist profit of 21. Alright, so for this type of problem, set MR equal to MC, find Q star. Then this next part is plug Q star into the demand curve and solve for the price. And then just calculate profit, which is revenue minus cost. And all that stuff will be given. Okay, so questions on what we did here? Okay, alright, so let me just get you guys started on the homework, and then I'll finish up for the night. Alright, so there's just one homework question for chapter 7 and one homework question for chapter 8. Both are due next week, but there's just one question. So chapter 7, this is like the last one we did in the example. Sorry, I guess there's two. I thought there was just one, but okay, there's more practice is good. So there's two questions here on pure competition. So you're given a total cost function and a marginal cost function for both of these, and you've got to find the best Q star and then calculate profits. Okay, and then for the chapter 8 one, that's on monopoly like we just did. Okay, so the chapter 8 one, you're given demand, total cost, marginal cost, and marginal revenue. You're going to just repeat the steps Part A, find the optimal Q star by setting MR equal to MC. Part B, plug in the Q star into the demand curve and find price, and then just calculate revenue, and calculate costs, and then calculate profit. Okay, so you should be able to look at the examples we did and use those as a reference for the homework questions. But any questions on what I want you to do for the homework assignments here? Okay, great. So if you have questions, we kind of went through a lot today, so hopefully you're able to, grab some of that information. That was 2 chapters, lots of information. So I had a couple double days scheduled, so hopefully you're able to grab some of that information, at least the homework questions. So the chapter 7 homework goes here, the chapter 8 homework goes here, and both of those are due next Wednesday. And if you have questions on those, then you can email me or let me know, and I'm happy to help. So I think that's it for tonight. We've already gone a little bit over time. Yes. Okay. So chapter 7 and chapter 8 homework due next week. Next week we'll talk about the next 2 market structures, which are monopolistic competition and oligopoly. And yes, so if you don't have any more questions, then you're good with the homework. That's it for tonight. And sorry a little bit longer, but thanks everyone for staying for over 2 hours. And enjoy the rest of your week, and stay safe, and thanks a lot.
Have a good afternoon.
You too.
Thank you. Thank you.
Thank you.
Thank you.